Okay, good morning students. So in the last session, we were discussing the chapter that is called as carbon and its compounds. Okay, as I told you, I am taking the four topics: carbon and its compounds, chemical reactions and equations, acids, bases and salts, metals and non-metals. In the previous section, in the carbon and its compounds, I have finished introduction to hydrocarbons, classification like alkanes, alkenes and alkynes. Then I went for the homologous series. The continued part we can start here, that is functional groups. Yesterday also I briefly told about this functional group. What is the work of this one? It acts as a reactivity part in the chemical reactions. Okay, and the different types of functional groups are, we have to see that, as I already told you before homologous series, that the different functional groups are, again I will be writing here. If you go for dash X, which is called as a halogen, okay, and the halogen consists of four things: fluorine, chlorine, bromine and iodine. And second one is dash OH, which is called as alcohol. Next one is dash C double bond OH, which is called as aldehyde. And next one is dash C double bond O dash, which is called as a ketone. And last two, it is carboxylic acid. So these are the different functional groups which come in the organic part. Okay. And last one you can take this one also, that is NH2, which is called as a amine. So as I told you, in homologous series or functional groups, how this has to be utilized. So I will take one example. If I take the compound dash C dash C dash C like that, which is called as a butane, and all carbons are surrounded by the different hydrogens, and when you remove one of the hydrogen and replace it by any functional group, that time you get the different compound. For example, if I put here Cl, it is called as a chlorobutane. So I had added a chlorinatom, and when you add the OH group, which is called as a butane 1-ol, okay, and next one, if you add the aldehyde group, it becomes a butanol. And one thing you remember, aldehyde group will be always at the first and last carbon, but the ketone group will be in the middle of the compound. For example, if I take CH3, CH2, C double bond O, CH3. So what will be this compound? This compound is called as a butane 2-on. So like this we are giving the compounds. And for a carboxylic acid, it should be also at the first and last carbon, CH3, CH2, C double bond OH, which is called as a propanoic acid. And last one is the amines. If you take, the compound becomes a methanamine, or it is called as a methylamine. So like this, functional groups you have to utilize in the compound. Any hydrocarbon you can take. Next one is, so what about benzene ring? If they ask, same thing you have to follow here. On the benzene, if you write Cl, it becomes chlorobenzene. If you write OH, it becomes a phenol. If you write a C double bond OH, it is called as a benzaldehyde. Similarly for all the compounds. Okay. Till this one we have discussed it yesterday. So now we continue to the next part, that is called as nomenclature of organic compounds. See, in 10th class briefly they will tell about the nomenclature, nearly 8 to 9 rules, and you know how to name the compounds also. But when you come to the PUC first year classes, there some rules are more, and you are learning one different concept that is called as a bond line formula. That also few examples I will explain in this part of the class. What do you mean by nomenclature? Nomenclature means naming of the compounds, of carbon compounds. First of all, identify the number of carbon atoms in a compound, and in it identify the longest chain. Then functional group can be indicated by suffix or prefix. What he told in this para, that I will tell you. Okay. So see, one second. So here what I am going to tell is that a nomenclature. So when they have given you some different compounds, that time first what you should do, if the compound is like this CS3, CH2, CH2, CH, Cl, CH3. If the compound is like this, first rule is identify the number of carbon atoms. How many carbon atoms are there? 5 carbon atoms. And how many extra group is there? 1 chlorine atom is there. Okay. And find the longest chain. Longest chain means the number of carbon atoms should be more. Like this, from first to last. You have to identify the compound. Okay. And after that, whatever the functional group is there, you have to make it as a prefix and suffix. Okay, leave that rules. I will tell you simple how to do by taking 3 or 4 compounds. Now for this one, what we should write? All contains a single bond, so you write it as a A. I come from the last to first. Okay, and how many carbon atoms are there? 5. So you write it as a pent. Whatever the myth, if the pent you are writing, it is nothing but called as a root word. Okay, and after writing this pentane, the chain has finished. Now go for the numbering. Number starts from here or there means I will tell you one thing. Wherever the functional group or extra part will be present, the numbering starts from there. But if more than one functional group is present in the compound, that time you have to go for the priority chart. That will be given in the chapter. For example, carboxylic acid will get the first priority, like that aldehyde, ketone, amines, halogen, like that. Who will have the high priority, they will get the lowest number. Lowest number means 1, 2, like that. Okay. So here no other substituent or functional group is there. Only one it is. So start the number from there. And when you start, you should write like this: 1, 2, 3, 4, and this becomes a 5. Where the chlorine atom is present on the second carbon, therefore you should write 2-chloro like this. Okay, and the name finished, but still some work is there. Before this, after this number and this prefix, that is starting word, you have to put the comma. Okay, and if 2 numbers are there, you have to put the hash, and all will be in the small letters. So the name of this compound is 2-chloropentane. Like this, you have to go on numbering. If I take more examples, then you can understand. Now we go for another example. CS3, CH2, CH, Cl, CH2, CH, OH, and here it is CS3. If the compound is like that, how to do that? Okay, everything is same. Only the problem is that there are 2 different functional groups. That time I told you, priority, who will be having the higher priority. This is alcohol group and this is a chlorine group. The alcohol group will get the first priority and the chlorine group will get the second priority. Therefore, what you should do, you should start the number from here. 1, 2, 3, 4, 5 and 6. The numbering work has finished. Now, which is prefix, which is suffix, you have to understand. The substituent or the functional group which has a high priority end with the suffix, and the functional group with the low priority end as a prefix. Therefore, what I will do, first I will go for the single bond chain. It is A. Okay, and I have to end with the alcohol. Alcohol suffix is OL, so you should write OL. Okay, and next, what are these? How many carbon compounds are there? They are 5. So write the root word, which is called as a pent. And now we come for the substituent. It is present at the 4th position. Therefore, you can write it as a 4-chloropentanol. Okay, pentanol. But another one thing you can do, sir, where is the alcohol group present? How to identify this? You can make like this also. Pent2-anol. By this, we can understand that the alcoholic group is present at the second carbon. Similarly, you can take many examples and go for the nomenclature. Now, we will go for third type of example. How it is? CS3, CH2, CH, CH2, CS3, CH2, 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 CS3. Like this, I am having the compound. So here, what you should do? There is no any functional group present here. Okay, but the chain is branched. That time, what we should do, according to rule, you have to find the longest carbon chain. So I will go for the longest carbon chain. If I start from here, 1, 2, 3, 4, 5, 6, 7. 7 carbons are there. If I start again from here, 1, 2, 3, 4, 5, 6. 5 carbons are there. If I come like this, 5 carbons, this becomes substituent. If I go like this, 7 carbons and 2 substituent. Now I will come reversely. 1, 2, 3, 4, 5, 6, 7. 2 substituent. If I go like this, again 7 carbons. So the conclusion is what? The 7 carbon chain is the longest chain. Okay. But now the numbering problem. Okay. If I use the number 1, 2, 3, this will get 3 number. If I start from here 1, 2, 3, 4, 5, this will get a 5 number. That time what you should do? You should select the functional group or a substituent group which has the lowest number. Therefore, I will give the number as 1, 2, 3, 4, 5, 6, 7. Now the 80% work is over. Now you should understand what is this group. It is not a functional group but it is a substituent group. C2 means 2 carbons, eth, and it is having H2 and S3, it becomes a ethyl. Okay. So third position is ethyl group. All is single bond, 7 are there. For 7 we will tell it as a set and we will end it as a A. So like this the name of this compound is 3-ethyl septane. Okay. So now last type of a different compound we can solve. CS3, CH2, CHCl, CHCl, CH2, COOH. I have taken this type of examples. That time, what is the problem here? Straight chain is there, carboxylic acid is present, and 2 functional group or substituent are present, but both are same, chlorine atoms only. For this, which type of rule you have to use? If more than one substituent are present and they are same, you should use the prefix di, tri, tetra, penta like that. Okay, and it is a long carbon chain. And another one point you have to remember. Wherever the carbons are there, you have to put the number. In carboxylic acid, C is there. Whether I have to count that or leave that means it also contains a carbon. You have to count that carbon also. Okay. Now comes to the priority. And when it comes to the priority, carboxylic acid is maximum and halogens are less. Therefore, the number starts from first. Okay. 1, 2, 3, 4, 5, 6. So like this, I am having the 6 carbons here. And I have to go for a substituent. Third is also chloro, fourth is also chloro. So that time what we should write? 3, 4. 3 chloro, 4 chloro, don't do like that. 3, 4, dichloro. Okay? And how many carbons are there? 6. Write X. All are single, write A. And for carboxylic acid, it ends with the oic acid. Therefore, end it as a oic acid. Therefore, the name of this compound is 3,4-dichlorohexanoic acid. Like this, I have taken 4 different examples. Still also I will take, and based on that, you can understand the nomenclature easily. So now we will go for some different concept. CS3, CH2, CH, CH2, CS3, CH, Cl, CH, OH, CH2, COOH. So how I feel I wrote the one type of a compound. Now this is a very multi-group compound. Like that, how to do that means? Again remember, prefix, suffix, root word, single bond. So if you remember all that, you will understand easily. Alcohol, chlorine, ethyl, carboxylic acid. Who will get the high priority? Carboxylic acid. So that you can start the number 1, 2, 3, 4, 5, 6, 7. Okay. Now the numbering are there, groups are there, easily you can follow. For the alcohol, suffix is all, but prefix is hydroxy. And ethyl, ethyl only. So what is the name of this compound? Means 5-ethyl, 4-chloro, 3-hydroxy, septanoic acid. This is the name of this compound. And one thing again you have to remember, under rule. Here 3 groups are there. That time, sir, I want to write chloro first, ethyl second. Hydroxy first, ethyl second. Can I write like that? So another rule is there. You should see the first letter E, C, H. Alphabetically, if you go, who will come first? C. So write 4-chloro first. Then you write 5-ethyl. Then you write 3-hydroxy. That is the another rule for naming the compounds. Okay. So after all the single bonds, I will go for a double bonded compounds. What is the rule there? Let's see. CH3CH double bond CH2. CH3CH triple bond CH. CH3CH triple bond C. CH double bond CH2. Okay, I have wrote the three compounds here. How to make them? I have to think. Whenever the compound contains double bond, that time what you should do is see, it will get the higher preference. Okay, so number starts from here or here means double bond will get higher preference. So write 1, 2, 3. How many carbons are there? 3. Right. From where is the double bond? That rule I am telling. Sir, double bond is present between 1 and 2. It is related to both. So I should write 1 in or 2 in means you should write 1 in. Why means the rule tells that if the double bond is there between two numbers, the lowest number is taken. Therefore, the compound becomes from 1 in. Okay, the name of the compound is like that. And when you come for a triple bond compound, they are also same. Start from the number 1, 2, 3. Again, write the same prop. It is present between 1 and 2. Prop 1. Triple bond is there. Therefore, you write Y. Y in A. Single, double, triple. Okay. So now the last compound I have taken, where double bond is also there, triple bond is also there. That time what you do, sir, means again one rule is there. What is that rule means? If double and triple bond are present simultaneously, double will have the higher priority, triple will be having the lower priority. Therefore, double bond will be late. Okay, 1, 2, 3, 4, 5. So number starts from 1, 2, 3, 4, 5. You can write pent. Finish. Where is the double bond present? Between 1 and 2. Where is the triple bond present? 3 and 4. So you can write as pent 3, 1, 4, E. What is the meaning of this one? The chain is pentane. It contains third carbon triple bond, fourth carbon double bond. The name of the compound becomes like this. Okay. So these were the few examples which again come under the rules. Okay. Now again, last part of the nomenclature I will tell you extra, which you not learned in the 10th class. Okay. What is that? See, which is called as a bond line formula. In some schools or civil syllabus they have finished again, but who don't know, they can follow this one. Okay, I will take 3 examples: CS3, CH2, CH2, CS3, CS3, CH double bond CH2, CS3, CH OH, CH, CN, CH2, CS3. I have taken 3 compounds. So if you want to take screenshot or whatever you are writing, you can name these compounds first, then you can go for the bond line. What is a bond line means? Every time writing CS3, CS2, 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 CS3, make the easiest method. How for the words we are making the abbreviations? See, for example, if you go for the ATM you are telling, you will not tell the automatic trunk dialer like that, STD, IST, you are using the brief things like that. Instead of writing continuously carbon and hydrogen chain, you can make it small. How to make it small means, how many carbons are there, you have to count that. 4 carbons are there, you have to consider them as a points and you have to draw like this. First carbon here. Second carbon straight line or what's up? No, you have to make it as a zigzag, mountain shape. So I will go for another one. Again mark this one as a second carbon. Then I will come for a third carbon. Then you come for the fourth carbon. Instead of writing this much, you can finish like that. So what is the meaning of this one? 1 carbon, 2 carbon, 3 carbon, 4 carbon. You can understand, sir, if I write like this, what will happen? I can put the points say 1, 2, 3, 4. No. If you write like that, it means only 1 carbon and another carbon are there. If you write like this, it is called as a bond. See how it means? CS3, CS3, CH2, 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 CH3. No need to write the hydrogen. Sir, can I write like this? No. Hydrogen means we can understand. Then, if I go for this compound, how to write this? Again 3 carbons. 1, 2, 3. First you join them. But the problem is here, between this and this double bond is there. For that, you should write like this. If you write this much, the compound will be drop 1 in. And if you go for the compound like this, 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5. 5 carbons finished. Second carbon is OH. Right. OH. Third carbon is CN. Right like this. is finished. Okay. So like this, you have to write the bond line formula for double bond and a single bond compounds. Okay. Next point. If the cyclic hydrocarbons are present, then you have to use the word prefix that is called as a cyclo. If there are two or more different substituents, they are listed in the alphabetical order. So I will take another one, two types of examples where you can learn what you mean by the cyclo compounds. Okay. If the compounds are cyclic, how to name them? Triangle, square, triangle Cl, triangle OH, triangle C double bond OH. If these are the few examples, the name is given as directly it is cyclopropane. Directly cyclo prefix prop 3 carbons in single bond. If it contains a double bond, that time you make it as cyclopropene and name you can give cyclobutane. This name is quite easy. And when you come for this one, it becomes fluoro cyclopropane. So like this we are having the few examples. Next one is cyclopropanol. Cyclopropanoic acid. So same things you have to follow for the cyclo compounds also. Okay. So now we will move to the other concept that is called as types of reactions. When you come to organic chemistry, there are many reactions. First one is addition, second one is substitution, third one is elimination, fourth one is called as a combustion. So one example I will give you for all the reactions. First one we go, that is called as a addition reaction. In addition reaction, what we are doing, adding some new compound but not removing or substituting any compounds. Okay. For example, if I take CH3, CH double bond CH2. Here what happens here? I will add the compound that is called as hydrogen. How many carbon and hydrogen are there in this compound? 1, 2, 3. 3 carbons are there. How many hydrogen? 3 plus 1, 4, 4 plus 2, 6. It is at 6. I am adding 2 hydrogens more. Therefore, what it should become? It should become C3H8. That is called as a propane. But how to add? All are satisfied. That time you remove this double bond. And when you remove this double bond, it becomes CH3, CH as it is, CH2 as it is. One double bond will finish and only remain with a single bond. And now I have to add 2 hydrogen here, 1 hydrogen here and 1 hydrogen here. So you get the compound which is called as a propane. So here I have added hydrogen. Nobody went outside. Only the 2 hydrogens came inside. It is called as an addition reaction. Okay. Second one reaction is substitution reaction. Substitution means what? You have to remove one person or element from there, and in that you place the new substance. So I will take example of methane, CH4 plus Cl2. What happens to this reaction? CH4 means C. 4 hydrogens are surrounded plus Cl. That Cl is there. Now what I will do? I will remove this one hydrogen. I will add one chlorine. That time it becomes hydrogen removed and Cl is added. I substituted. It becomes CS3 Cl. And whatever the extra persons are there, they will go outside as the gas. Therefore, I substituted this hydrogen by this chlorine. It is called a substitution reaction. Third one is elimination reaction. What do you mean by elimination reaction? Eliminate means already you know, to remove completely. So which type of examples will be suitable for that elimination? Let's see. If you take the compound that is called as alcohol, CH3CH2OH, which is called as a ethanol. To this, if you add H2SO4, which is concentrated. All of you know that concentrated H2SO4 means removal of water, dehydrating agent. If I remove the water from this compound, it becomes a different compound. See how it becomes? CH3, CHOH is there. Remove OH here, remove H here, this becomes a double bond and we get the compound CH2 double bond CH2 plus water. Therefore, the water is eliminated. So, like this, we are having the three different types of reaction. And another one we can see that is called as a combustion reaction. What is that combustion reaction? One example I can take. Combustion reaction. Combustion is already you know which is called as the process of burning. What is that burning? I will take one example by taking hydrocarbon CH4. CH4 plus O2 is equal to CO2 plus H2. Here you can see what is this compound methane reacting with oxygen, and when it reacts that time it is completely burned, and when it is completely burned it nature, then I will end the class and in the next session we will go with another chapter. So what are the different examples I am taking? Let's see. CH3, CH2, CH2, CH, double bond CH, CH2, OH. So how to nomenclate this and write the bond line formula? 1, 2, 3, 4, 5, 6. 6 carbons are there. I will write like this. One double bond is there. Numbering starts from there. 1, 2, 3, 4, 5, and 6. The substituent is OH, which comes as a higher priority. Another one is a double bond. Therefore, what I can write is hex 2 E 1 odd. Okay. The meaning of this one is hex is given, 2 is there, E 1 odd, like this. And when we use the name, what is the bond line formula of this one? 1, 2, 3, 4, 5, 6, and here OH is there, and here double bond is present. This is the bond line formula of the compound. And when we only give the name and how to write the compound, that also I will tell. 4 chloro 3 methyl pent 4 ene. If we use the name, how to write the compound means directly first concentrate on the root word. Write the number of carbons. 1, 2, 3, 4, 5. 5 carbons you are writing. Next you go for double bond. Fourth place is there. 1, 2, 3, 4, 5. While writing the structure, the number putting is on your desk. Okay. Fourth place. So double bond is here. And next one is 3 methyl and 4 chloro. Here methyl group is there and 4 chloro is Cl is there. Now balance the valency of the carbon. CH2, CH, CH2, CH3. So this will be the structure when you use the formula. And what is the bond line formula? 1, 2, 3, 4, 5. Double bond here. And here it becomes Cl. Here it becomes the CH3 compound. So like this, you have to nomenclate the organic compounds. So this is all about the chapter which is called as a carbon and its compound, which you learned in the previous 10th class and which will continue again in the PUC first year. Okay, thank you.